I welcome you to my YouTube channel. In this video, I am going to discuss few numericals in colligative property. How to calculate amount of substance required, and how to calculate freezing point and boiling point of the solution, and how to calculate the molar mass, and how to calculate the percentage of association or dissociation, and calculating the osmotic pressure. Watch this video till the end so that you can surely get minimum 2 to 3 marks in your public. So these are highly expected topic. Let's get started. Calculate the mass of ascorbic acid, whose molar mass is 173 gram per mole, to be dissolved in 75 gram of acetic acid to lower its freezing point by 1.5 degrees Celsius. Got it? In this question, you should first know which is the solute and which is the solvent. Here you read ascorbic acid to be dissolved. When solute is dissolved in solvent, you get a solution. So this is our solute. It's going to be dissolved. Solute is a substance. It is dissolved. The solvent is the one which dissolves it. So ascorbic acid is our solute, and the solvent is our acetic acid, right? Listen. So when you prepare the solution, one of our colligative property is solution's freezing point is lower than solvent freezing point. You want to lower the solution freezing point by 1.5 degrees Celsius. Then the quantity of acetic acid taken is 25 grams. They are asking you how much gram of ascorbic acid to be dissolved in 75 gram of acetic acid to lower the solution freezing point by 1.5 degrees Celsius. This is the question. Data are very important. If you know how to extract these data from the question, everything is going to be easy. Here, just know that 1 can be assigned for solid, subscript 2 can be assigned for solute. And the M, capital letter M represent molar mass, and the letter W represent mass. M represent molar mass, number 2 represents solute, molar mass of solute. Here, which is the solute here? Ascorbic acid is the solute. This ascorbic acid's molar mass is given, so you can write this data 176 gram per mole. And delta TF is nothing but depression in freezing point. Again, the W is mass, 1 represents solvent, the mass of solvent, 75 gram. And the KFS, cryoscopic constant, you have been asked to calculate the mass of ascorbic acid. So next thing is to know which formula to be written. So this is the formula. If you remember this formula, you can attempt three types of questions. One is to find out what is the depression in freezing point. Another is to find out amount of substance. Another is to find out molar mass of the substance. Got it? So in this question, they're asking me to calculate mass of ascorbic acid. So I'm going to rearrange this equation in this form. Got it? So now what should I do? Simply substitute all the values. So delta TF value here is 1.5. M2 value here is 176. And W1 value here is 75. KF value here it is 3.9. So if you simplify this, you will get 5.077 gram, which means that if you weigh 5.077 gram of ascorbic acid and dissolve in 75 grams of acetic acid, now the solution freezing point will be lowered by 1.5 degrees Celsius. I hope you understood. Let's go to the next question. Calculate the freezing point of the solution containing 60 gram of glucose, molar mass 180 gram per mole, in 250 gram of water. Got it? So in this one, first thing is to find out which is solute, which is solvent. Right? Here, glucose we have taken in water. Here 60 gram of glucose is taken and dissolved in 250 gram of water. So solute is the one which is taken in smaller quantity. Solvent is the one which is taken in large quantity. So if you remember this, and you can easily find what is solute, what is solvent. Solute, less amount. Solvent is taken in more amount. So 60 less 250 more. So glucose is my solute and water is my solvent. Then write all the data, given data, and how much is the mass of glucose taken it is 60 gram. So mass of glucose, how I can write? Sigma for mass, I'm going to use letter W. Since glucose is acting as a solute, I'm going to use number 2. Solvent here is water. So for mass W, for solvent, I'm going to use subscript 1. Yeah. And it is 250 gram. And the name 2, molar mass. M means molar mass. 2 represent solute. Here solute is rubber glucose. Molar mass of glucose is given in the question itself. And the Kf value also given. So we have written the data is given. And then what they're asking you to calculate what's the freezing point of the solution. Correct? Which means that they're asking you to find out TF. Most of the students commit a mistake here. So delta TF refers lowering of freezing point. TF refers freezing point of solution. You cannot find the TF without finding delta TF. So how to find out this? The same formula what we used before. So I need to find out lowering of freezing point of solution. So I'm going to use this equation as it is. I'm going to substitute all the data. AF value is 1.86 and the W2 value is 60 gram. And here I have M2 value is 180 and then weight of solvent here is 250. If you substitute and simplify this, you will get answer as 2.48, which means that if you dissolve 60 gram of glucose into 50 gram of water, so solution freezing point is lowered by 2.48. Now the next formula what you should know is delta TF is equal to TF naught minus TF. Got it? So what will I now do? I have to find out TF. So I'm rearranging this equation. So after rearranging this, I will be getting this. And then what is this TF naught? Naught means it is pure. Clear? So pure solvent. So here, what is the solvent we use? What is the solvent we use? So you know that freezing point of water is 0 degrees Celsius. Got it? But here you have to substitute all the values in Kelvin. In this test, student commit mistake. Please be very careful. Here you have to substitute temperature in Kelvin scale. So water, this is at 273 Kelvin, and then the delta TF value we just found here 2.48. So if you find the difference, you will come to know at which point the solution freeze. The same thing you can do it for boiling point as well. So for boiling point, what is the difference? The place of AF I'm going to use B. The place of AF I'm going to use B. And then there's a small difference in this formula. So delta TB is equal to TB minus TB naught. That's it. If you know these two small differences, you will be able to calculate what's the boiling point of solution. Got it? Let me move on to the next question. Solution is prepared by dissolving 10 gram of non-volatile solute in 200 gram of water. It has a vapor pressure of 31.84 mmHg at 308 Kelvin. Calculate the molar mass. So we are going to calculate molar mass of the solute. So in this question, they have simply mentioned you are preparing a solution by dissolving 10 gram of non-volatile solute in 200 gram of water. Everything is given. What is solute and what is solvent? Everything is given in this question, so you don't have to bother. So the question, the vapor pressure of pure water also have been given. So this question was asked in 2023. So let us write the given data. So W represents mass, 2 represents solute, W2 is mass of solute. Mass of solute is 10 gram. W represents mass, 1 represents solvent. Mass of solvent you have taken is 200 gram. The temperature at which that experiment is done is at 308 Kelvin. So I have written it. And then PA naught. So P represents vapor pressure. A you can write as you can think of as solvent. And then naught is pure. Wherever naught comes in this case, pure. Clear? So the pure water vapor pressure is 32 mmHg. I have written it. And then PS here is vapor pressure of solution. So after dissolving 10 gram of non-volatile solute in 200 grams of water, the vapor pressure is lower to 31.84. Here the molar mass is M, and then one solvent M1 is equal to 18. So because water molecular mass is 18 gram per mole, they are asking to find out what is the molar mass. Vapor pressure data are being given, so I'm going to use relative lowering of vapor pressure. So this is the formula Pa naught minus Ps divided by Pa naught. Got it? So it is going to be equal to N2 divided by N1 plus N2. What it is? Actually, it is a mole fraction. Okay. So but here you have N1 plus N2. So if you add N1 with N2, which means number of moles of solvent, and N2 refers number of moles of solute. Since you are preparing the reliable solution, the summation of N1 plus N2 can be equated as N1. So I'm going to simplify this term as N1 here. Got it? So N represents number of mole, 2 represents solute, number of moles of solute, divided by number of moles of solvent. Okay, so let us now substitute the values here. Pa naught here is 32, Ps here is 31.24, Pa naught again 32, and then here I'm going to calculate number of moles of solute. What's the formula? It is mass by molecular mass. It's very simple. What's the mass of non-volatile solute taken? It is 10 gram. So 10 divided by molecular mass of solute, you don't know. So let me take it as N2. Got it? And then here, I'm going to find out number of moles of water. Finding number of moles of water, what's the formula again? Mass by molecular mass. So mass of the water taken here is 200 gram. Molecular mass of water is 18. So 18 is brought to the numerator. So I need to find out what is the molar mass. So what should I do now? I'm going to rearrange this equation. So difference is 0.16 and I need to find out M2. So I'm going to stack these terms. Got it? What's the empty value I got? 180 gram per mole. Let's move on to the next question. Freezing point of solution containing 5 gram of benzoic acid. Benzoic acid molar mass is given as 122 gram per mole. It is dissolved in 35 gram of benzene and is decreased by 2.94 Kelvin. What's the percentage of association of benzoic acid if it forms a dimer in solution? Here is given. This question is asked in 2020. Solve this question step by step. If you want to find out what is the percentage of association or dissociation for everything, what you need is I value. So delta TF value depends on molality. So first thing, what I need to find out what is the molality of the solution. So you have taken 5 gram of benzoic acid, which is dissolved in 35 gram of benzene. Okay, delta TF value is given to be 2.94. So after adding 5 grams of benzoic acid and 35 gram of benzene, the solution freezing point decreased by 2.94. So the Kf value is given to be 4.9 Kelvin kilogram per mole. So the M value here is the molality of the solution. Right? And I value here is Vita factor. So let's now start finding M now. So how to find out M? Mole number of moles of solid divided by mass of the solvent in kg. So we don't know the mole and in the question, they have given the weight of solvent in terms of gram, and then I need to convert it into kilogram. So these two things I need to first find out. So finding moles of benzoic acid is again going to be easy. So mass by molecular mass. Mass of benzoic acid is 5 gram, and the molar mass is 122. So if I do that, I will be able to calculate the number of moles of benzoic acid. Okay. Then I need to convert the gram into kilogram. So what should I now do? So dividing it by 1000, I will be converting gram into kilogram. So simply what should I now do? I have to substitute this value and then I found the molality of the solution I prepared is 1.171. Okay, the step number 2 is to relate the delta TF with the Vita factor. So here what should I now do? I have to find out what is I value because the benzoic acid I have taken is undergoing dimerization, which means that there is going to be the difference in the number of particle percent, right? Finding I value, I'm going to rearrange this equation. So in this equation, the 30 value I know, A value is given in the question itself, and then the M value I know it, and then what I found here, 0.512, it is less than 1, so I can understand that it is undergoing association. Here I have taken benzoic acid, and formula of benzoic acid is C6H5 COOH, so 2C6H5COOH is going to form one dimer. So then if you consider the initial mole of benzoic acid taken to be 1, then in the beginning there was no formation of dimerization of benzoic acid, so it is 0. So if you consider fraction of moles of benzoic acid undergoing dimerization, So here, two molecules of benzoic acid required to form one dimer. Got it? So for 2, we get 1. So which means that for alpha, I will be getting alpha by 2 to find out the total number of moles after this undergoes association, right? So here the number of moles of benzoic acid is 1 minus alpha, and the number of moles of dimer here is alpha by 2. If I simplify this, I will be getting 1 minus alpha by 2. Got it? So here what should I now do is, I'm going to find out what is the Vanta factor. The formula to find out Vanta factor is number of moles after the association is 1 minus alpha by 2, and number of moles before association is 1. Okay, so if I simplify it, I will be getting 1 minus alpha by 2. In the place of phi value 0.512 and 1 minus alpha by 2. So I can swap these two terms so that alpha by 2 becomes equal to 1 minus 0.512. So difference I will be getting 0.488. Got it? So from this, how can I find alpha? So by this way, bringing this term to the other side, I will be getting alpha value as 0.976. Okay. So from this, I can easily find what is the degree of dissociation. Got it? Okay, let's move on to the next question. Determine the osmotic pressure of solution prepared by dissolving 25 mg of K2SO4 in 2 liters of water. Assuming that this experiment is performed at 25 degrees Celsius and assume that it undergoes complete dissociation. Right? Let me tell you how to answer this question. The formula to find out osmotic pressure is pi is equal to ICRT. Just know that you know all the terms for finding osmotic pressure. The first thing is to find out the molarity of the solution. What should I do? I should know what is the molar mass of K2SO4. Molar mass of K2SO4 is not given, so you need to find out. So here I have 2K. So let me write 2 into atomic mass of K, and then plus I have only one S, 1 into atomic mass of S, and 4 oxygen atoms are there, 4 into oxygen. Now what I have to do? I have to substitute the value of atomic mass of potassium. Atomic mass of potassium is given as 39. Atomic mass of sulfur is 32. Atomic mass of oxygen is 16. So if I substitute and then simplify it, I will be getting 174. So this is the molar mass of K2SO4. So mass given here is 25 mg. So I need to convert it into gram. So converting into gram, dividing it by 1000, I will be getting. So it is 0.025. So to find out number of moles, I will use this formula mass by molecular mass. Mass of K2SO4 is 0.025. Molar mass is 174. Simplifying it, I will be getting this very number of moles of K2SO4 is taken. Then finding molarity, what I have to do? Mole by volume of solution in liter. So moles, I know it is 1.47437 into 10 to the power minus 4. Okay, the volume of solution in liter, it is given here, it is 2 liter. So if I simplify it, I have found what is the molarity of the solution. Then here, finding the Vanta factor. K2SO4 undergoing dissociation, I have only K, so 2K plus will be found, and then how many SO4? 1 SO4 is there. So in total, I will be getting 2K plus 7 and 1 SO4 minus, the value is going to be 3. Got it? So now I have got everything I need, so I'm going to simply substitute. I know the value of 5, I know the value of 4 concentration, I know the value of R value, I mean gas constant, and T. Everything we need to just substitute it here. Store it down from further the value of R. What is the value of R here? So 0.02. And temperature also often student from the question. So temperature is written here in Celsius. You need to convert it into Kelvin. So conversion, what should I do? Adding 273. 273 with degree Celsius, you will be getting Kelvin scale. Okay, so if I simplify it, you will be getting the value of pi. I hope you understood. Thanks for watching.